Hi, everybody. It's Professor Mitchell, and now we're going to talk about 1.3, which is more about functions. So you probably just watched recently 1.2, where we got into really reviewing functions. So now we're going to get a little more deeply into it. So you'll notice on this list of objectives that some things are crossed out. So these are things that I am saving for pre-calculus. So after you take trigonometry, you will take pre-calculus, and then you'll learn all about increasing, decreasing constant functions, maxima, minima, and piecewise functions. So in this class, we're just going to talk about even and odd functions, which includes symmetry. And we're also going to start talking about difference quotients, which is really, really important for Calc 1. We'll talk about maybe easier examples in this class. We'll get into some slightly harder ones in pre-calc. And then you will be difference quotient experts by the time you get to Calc 1. Okay? So the first thing we have is even and odd functions. So a function is called even if it has this property that f at opposite x is equal to f of x for all x in the domain of f. Okay, so I found this picture on Google Images. So over on this side of the graph, here is some number x, and up here, that y value would be called f of x. So let's say, just for example, that this is the point 3, 4. All right. So the definition is saying that f at opposite x has to be equal to f of x. So over here, you have opposite x, which in my example would be -3. And if you follow -3 up to the graph, you hit the same y value. You see that these 2 points have the same y value, which I'm calling 4. Okay. So one thing that comes out of that right away is that even functions, when you graph them, are symmetric with respect to the y-axis. So if you're ever asked to identify a function as even or odd, the next thing we'll talk about is odd functions. Most functions are actually neither even nor odd. All right. If they give you the graph, you can tell by looking at the graph, and if they give you the equation, you can also tell by working with the equation, and we're going to do an example of that. Okay. So before we get into any examples, let's talk about odd functions. So odd functions have a similar property. A function is called odd if f at opposite x is equal to the opposite of f of x. Okay. So what even and odd functions have in common is that they both have to do with f at opposite x. Okay. If the function is even, then f at opposite x is exactly the same as f of x. But if it's odd, then it's the opposite of f of x. Okay. And this graph would be an example of that. So, of course, they could not make this simple by just putting this x value right on a line. So let's say that this x value is 1.7. All right. If I follow 1.7 up to the y value, it looks like it's 3. Okay. But then if I went over here to -1.7, that would go down to -3. Okay. So odd functions also have a certain kind of symmetry. They are symmetric with respect to the origin. Now, origin symmetry is a little harder to describe. Imagine taking the right side of the graph and actually rotating it 180 degrees all the way around. So in other words, if I took this piece here and just rotated it, it would sit over top of this piece. Okay, so the origin acts like a mirror. All right, you take this part and then flip it upside down to get the part on the left side. Okay, so that's how you tell from a graph whether a function is even or odd. Again, let me just go back real quick if I can. Yeah, even functions have y-axis symmetry. The whole y-axis is like a mirror. Looks the same on the right side as on the left side. And then odd functions have this origin symmetry. Okay. If your graph does not have either one of those two kinds of symmetries, then it is neither even nor odd. Okay. So now let's talk about what it looks like when you have an equation. Okay, so the first example, we're going to determine whether this function, g of x equals x to the fourth minus 3x squared, is even, odd, or neither. So here's how you do that. You always start with you always start by replacing x with opposite x. So that's what I have done here. Okay. So when I replace x with opposite x, I have opposite x to the fourth minus 3 times opposite x squared. Okay. Now, because these exponents are even, you probably know that when you raise a negative number to an even power, the answer is positive. Okay. So what that means is that the fourth power of opposite x is exactly the same as the fourth power of x. And the second power of opposite x is the same exact thing as second power of x. So in other words, replacing x with opposite x makes absolutely no difference. It gives you back the original function. So that means g at opposite x is exactly the same as g of x, and that makes this function even. Okay, so the next example, which I'm going to give you, I'm going to ask you to pause the video and try this one first. We're going to determine whether the function h of x equals x to the fifth plus 1 is even, odd, or neither. So pause the video, try that, and then we'll compare notes. Okay. So remember that the way that you determine whether a function is even or odd is by looking at h at opposite x. So this one I did not break down the way that I have broken down all the others. So let me turn on my pointer. Okay, so here is h at opposite x. Opposite x to the fifth power plus 1. Now, the fifth power is an odd power. And when you raise a negative number to an odd power, it comes out negative. All right. So, for example, the fifth power of negative 2 is exactly the same as doing 2 to the fifth power and then just making the answer negative. Okay. So, on the one hand, h of x is x to the fifth plus 1. But h at opposite x is negative x to the fifth plus 1. So those are clearly not the same. And that means this function is not even. Okay. Now, not even could mean odd. All right. So let's try if we can see if we can make it odd. So here's h of x. H of x is x to the fifth plus 1. And we already know h at opposite x is negative x to the fifth plus 1. So what we're doing here is we're trying to see, is that the same thing as just doing negative h of x? So negative h of x means just make the whole thing negative. But the problem with that is that it would also make the 1 negative. So here is h at opposite x is negative x to the fifth plus 1. Opposite of h of x is negative x to the fifth minus 1. And because those two are not the same, this function is not odd. This function is neither even nor odd. Okay, and that brings us to difference quotient. This is a very important concept in Calc 1. Actually, throughout all of calculus. But Calc 1 is really where we kind of beat you over the head with it. So this expression, f at x plus h minus f of x all over h, that is called the difference quotient of the function f. It has a little bit to do with slope, believe it or not. Okay, and you'll probably hear all about that in either your pre-calc or your Calc 1 class. Okay, what we're doing in this class is just kind of practicing I would say, kind of the simpler examples of difference quotient. So the first example is f of x equals 3 minus 4x. for that function, f of x equals 3 minus 4x, and they will always give you a specific function to do this with. We want to find and simplify the difference quotient, which is this thing. Okay? So I've got that all laid out in here. The first thing that I often like to do is just figure out the f at x plus h part. So I'm doing that part separately. Here is f at x plus h. So notice that I have x plus h in red. I'm trying to emphasize that all I've done is replaced x with x plus h. Okay. And so now I'm going to pick that up and put it inside my whole difference quotient. So again, I have this kind of color coded. So here is my f at x plus h. Notice that that part is exactly the same as what it is up here. And then I have to subtract the f of x. Very, very important that you remember to put the f of x in parentheses. You're subtracting the whole entire f of x. So make sure you put that in parentheses. Okay. And then what should happen, if you play your cards right, by distributing the -4 over x plus h, and then distributing the negative sign over the 3 minus 4x, I'm going to try once again to use the pen because I did not put this in here. Notice that the 3 and the -3 cancel, and also the -4x and the 4x cancel. Okay. And so what that leaves me is just -4h on top. And what I was starting to say a moment ago is if you play your cards right, every single term on top should have an h in it. And what that allows you to do is to cancel the h's from the top and the bottom. And in this case, it just leaves me with a -4. And I should put a disclaimer on this that the only time I'm allowed to cancel that h is when h is not 0. It's not a big deal if you don't remember to say this, but I'm going to try to remember to say it. Okay, so that was the I do one, and here comes the you do one. All right, so we're going to have you try if f of x equals -2x squared plus x plus 5, we're going to find and simplify the expression, the difference quotient. So the same expression, f at x plus h minus f of x all over h. So pause the video and try that, and then we'll compare notes. Okay, so let's compare notes. So the first thing I'm going to do is the f at x plus h part. So for that, again, remember you're just replacing x with x plus h. So here's what it looks like when you do that. Now, the thing that you may or may not have remembered is that when you square a binomial like x plus h squared, there's a specific way you have to do that, right? You can't just say x squared plus h squared. You either have to write x plus h times x plus h and then FOIL it, and that's how you get this. Or there's also a special pattern for squaring a binomial that sometimes we talk about in our algebra classes. So either way that you do it, you should get that the square of x plus h is this thing, okay? And then over here you have your plus x plus h plus 5. So this part over here is really easy. In fact, you can just drop the parentheses when you get down there. And then here you just have to distribute your -2. So that gives you -2x squared minus 4xh minus 2h squared. Okay, so that whole monster thing is just the f at x plus h part. Okay, so now we're going to drop it into the whole difference quotient. Eee, doesn't that look fun? So here is the f at x plus h. It's all this part right here. This part is what we got on the last slide. This part right here. And then remember what I said in the last example about when you subtract the f of x, you have to subtract the whole thing. Okay. So now when you distribute your negative sign, that negative 2x squared is going to become 2x squared, plus x is going to become minus x, plus 5 becomes minus 5. And then something really exciting should happen. You should get a whole bunch of stuff to drop out. Look here, the negative 2x squared and the 2x squared drop out. The plus x and the minus x drop out. And the plus 5 and the minus 5 drop out. And that leaves you with just negative 4xh minus 2h squared plus h. All those terms have h's in them. So now you can factor out the h, and that just leaves you negative 4x minus 2h plus 1. And you can cancel your h from the top and the bottom, which leaves you with negative 4x minus 2h plus 1. And again, if you forget to write h does not equal 0, I will not get upset.